Hello and welcome to this tutorial on WAN circuits and speed. Whether you're connecting two remote LANs with a private point-to-point circuit or you're just purchasing internet connectivity for your enterprise, you're going to have to deal with WAN circuits. And there are a bunch of different options to go with, and they all differ primarily in the speed that they can push information. So how much bandwidth is available? So we're going to look at the base unit of speed that all of the circuits are formed off of, that they're all based on. And once we get an understanding of that, we'll take a look at all of the different circuit types, at least all of the different traditional circuit types, because there seems to be always a new offering of some kind coming out. And we'll check out the corresponding speeds for those circuits. Okay, let's get started. Okay, the base unit is known as a DS0. So DS stands for digital signal, and 0 is just the first number they chose to begin with. And the DS0 is equal to 64K per second. So 64,000 bits per second, or 64 kilobits per second. That is the standard unit. And all circuits that we talk about are based in multiples of the DS0. So first, some background information on the DS0. Originally, when telcos were providing voice services, they determined that in order to provide good quality, they had to sample a person's voice 8,000 times every second. And then each one of those samples was assigned an 8-bit representation. So 8 bits for each sample, and it was done 8,000 times for 1 second of voice. So 8,000 times 8 gives you 64,000 bits per second, or 64K. And that was equivalent to 1 second of voice. And so that became the base unit. And when everything went digital, they kept that base unit. And all of the data circuits now are based off of that same base unit. So there we have it, DS0 and 64K. So let's check out some of the circuits now that are based on this measurement. And here we have circuit speeds. So DS0, 64K. The first one we come across is a DS1. And it's also called a T1. And that is equal to 1.544 megabits per second. So what that means is there are 24 DS0s in a T1. So we've grouped 24 of them together. Now if you do the math, it falls a little bit short of the 1.544. That's because there's something called overhead in terms of framing and making the circuit work. So there's an extra 8 kilobits per second added on there. But the multiple of 24 DS0s is there. Those are often referred to as channels. Sometimes it's a channelized circuit where you can pick out each channel individually. Sometimes it's not. It's just a clear channel where they all look as one big channel. The next increment is a DS3 or a T3, and that's 44.736 megabits per second. So this is the next step up, also called the T3, and that is actually 28 DS1s plus, again, some overhead. So you've got the DS0, 24 of those to get a T1, 28 T1s equals a T3. So you can see how, again, everything is building off of each other. Now it gets a little bit different when you come to E1s, because those are commonly used outside of North America. So South America and Europe commonly use the E1 format. And the standard E1 comes in 2.048 megabits per second, so a little bit bigger than the North American T1. And of course there is a larger circuit as well, the E3, which is just a little bit over 34 megabits per second. Finally, there is the J1, and this is the implementation in Japan. And it's a little bit different in terms of the formatting, but it also comes in just over 2 megabits per second. So those are the different speeds. Those are the different circuits corresponding to the speeds, and that's it. Those are WAN circuits and their related speeds. So just keep in mind, to summarize, the 64 kilobits per second is our base unit, and everything else comes in multiples of the DS0. Okay, that's it, folks. Thanks for watching.